Hello, friends, developers, engineers of all stripes. Ken Briodagh here, Editor-in-Chief of Embedded Computing Design, and I'm still here at Embedded World 2026 in Germany. We're having a great time. We're checking out all of the best, most interesting tech and toys and gadgets, and I am very excited to be here in the u-blox booth. I'm about to talk to my friend Kevin. Welcome to the show.
Welcome.
Really a pleasure to have you. We're going to talk about your F11, and it's a really interesting piece of kit. But before we do that, let's talk a little bit about GNSS and how that plays into everything that you guys have been working on.
Yes. So GNSS is very important for, especially in our case, in terms of the F11 that I'm going to go into further, for battery-powered devices. So really low power tracking devices used in pet tracking, people tracking, sports and fitness tracking, but also fleet tracking, where you track containers, cars, and so on.
Right. A lot of folks think of Bluetooth, especially BLE, as an alternative to GNSS. Why do you like GNSS for those use cases?
So GNSS really addresses where you want to locate something, and Bluetooth is more kind of a communications device.
Fair enough.
And for low power GNSS, it's more important to locate something in a specific accuracy.
All right, that makes sense. So let's talk about the F11 though. How does the F11 tap into that?
Yeah, so traditionally, a lot of low power devices are based on just using the L1 band to do GNSS. But with the F11, we're introducing single band and dual band in one single solution.
Really? That's cool.
And this has a lot of benefits, because now we can combine the low power of L1 with the accuracy of a dual band receiver in one device. So for situations where you have a nice sky view, you might only need L1, so we use only the power to maintain accuracy.
Power,
exactly. But when we go into more challenging environments like urban canyons or a forest with trees, we are automatically switching on the L5 band to maintain that position accuracy. So we made here a really new innovation where we are situationally aware of the environment and the signals. So we adapt to those conditions automatically to unlock a next level of efficiency.
It's really smart, and I can see the function, especially in the types of asset tracking things or supply chain tracking, where your thing is on the move. You've got to know where it is. You might be in a tunnel, you might be in a forest, or you might just be out in the open, and being able to keep that power low by switching to the L1 makes a lot of sense. So with those kinds of things in mind, do you ever expect to lose location with the F11, or is it pretty much always there?
No, we also have added a feature called indoor detection.
See?
Because there might be situations where you go inside with a tracker, and then you don't want to waste this valuable battery or power. So we then give the host interface or the host MCU the choice to switch off the GNSS to save power, and maybe try later when you're outside again to acquire satellite signals again.
That's incredible. That's really cool. Well, thank you so much, Kevin, for talking to me today. This is really great. Folks, don't go anywhere. We've got lots of cool stuff happening here at Embedded World 2026 in Nuremberg, Germany, and this is the only place to get it. We'll see you soon.